Maybe.
Oh. Right, can you hear me now?
Yeah.
Cool, okay. This is very distracting. So I've got two distractions now. The first one is this thing. The second, but it does make it easier to talk because I'm losing my voice, so now I don't have to shout, which is great. The second distraction is the fact that I was a very, very naughty boy, and when I sent Kiara my slides, they weren't in accordance with the corporate template, so she's completely changed my slides, so that will confuse the hell out of me, so it will then confuse the hell out of you guys. So we'll just wing it and see how we go. But anyway, the idea of this talk is, how many of you here have had the misfortune to read one or other of my blogs on our website? Okay, that's not too bad. So, as you probably know from those blogs, I write a lot of words, I say a lot of words, and I come up with all sorts of strange ideas. So really the idea of this presentation is to just talk a little bit about some of those strange ideas. Some of those ideas are in one or two of those blog posts. Others you've possibly never heard of, other than, you know, maybe a conversation with me at some stage. Most of these things I would say are in a usable state. Some of them we're thinking about, you know, we can productize this stuff and do more with it. But what I'm hoping to sort of get across today is that, you know, we are exploring new and different things. We're thinking about how we can help to solve customer problems, where one of the problems that VMS has had over the years is, very sadly, is we've had a gradual decline of, you know, ISV products for Open VMS. For example, I'll talk a little bit about Opportunity, who were acquired by Click, and then Click decided they weren't going to do Open VMS anymore. So, you know, there are quite some number of customers that use Opportunity Click in their Open VMS environments. So that causes a problem for those customers. Can we do something to help? You know, there are other solutions, potentially compliance and so on and so forth, that might also be useful in that space, but is there something that we can do to help? So it's really just talking about some of these solution ideas and maybe get you thinking about how you might be able to solve problems that you've got within your business, either directly taking some of the stuff I talk about, or maybe it will just trigger a crazy idea on your part. So we'll see how we go, and we'll try and get through some of this stuff. So brief introduction, I've probably done that already. And then I've got a number of topics there. I'm going to talk about deck message queue. Everybody knows that Brett likes message queuing and things like that. So talk about a solution that we worked on for replacing deck message queue. I'll talk about the Opportunity Click side of things, some other ways of interacting with the MQ series, like MQ. The fact that we no longer have Oracle Classic or the Oracle Classic client on OpenVMS supported, what can we do there? And then some more general bits and pieces around data access solutions, interacting with RDB in new and curious ways, and some random bits and pieces. So we'll see how we go. There's quite a lot of slides, and you know, if I talk fast enough, we'll get there. We'll see. So, like I say, I mean, most of these things are, you know, it's a wet day in Christchurch, New Zealand. I'm sitting around twiddling my thumbs, or I'm walking the dog, or something like that, and some random idea will come to me. And then my wife gets really annoyed because I spend the rest of the day sitting on the couch hacking away on some code. And sometimes these things just turn to nothing and they get thrown in the garbage bin, and sometimes they actually develop into something that might be vaguely useful to someone. So, first topic is deck message queue, which has been around for a long time. Message queuing is nothing new. You know, message queuing started way back in the 80s, and you know, then, as was the way in those days, that all the big guys like Digital, HP, well, not so much HP in the space, but Digital, IBM for sure, started jumping on the bandwagon and developed their own message queuing products. None of these products talk to each other, of course, because there were no such things as common standards for these kinds of interfaces back in those days. But this book on rabbiting queue is written by a friend of mine, Alvaro, who now works for Microsoft. But the diagram is taken with Alvaro's permission from his book. And I couldn't help but comment to Alvaro last time I caught up with him that there's something missing on the diagram. He'd made this wonderful diagram with all the message queuing products and so forth. He'd left out deck message queue. Hadn't even heard of the darn thing, didn't know it existed. So deck message queue was Digital's product, originally just for OpenVMS, but it was Digital's message queuing product, the OpenVMS operating system, and then ported to other operating systems as well. It saw really rapid adoption. It was actually a very, very good message queuing product. Now, it does do some things which I don't consider message queuing, a little bit naughty, but that's another story. At the end of the day, it was a great product. It was widely used, ported to many platforms. You can use it from just about any programming language. Very popular, in particular in financial services, manufacturing, telecommunications, but really a good general purpose message queuing solution. True to form, Digital was a stunningly bad marketing company. And this in the grey box there is something I found on the internet where some people have done a review of these various message queuing solutions that were around at the time. And they concluded that Deck Message Queue was, basically number one. It was the best product, but there was absolutely zero marketing. So Digital, once again, could have done an awful lot better with Deck Message Queue than they actually did if they actually knew how to market the damn thing. But that's history. Towards the end of the 1990s, it was sold to BEA Systems along with a number of other products. And then BEA Systems was acquired by Oracle in 2008. I think that was actually at a Bootcamp event. I can remember actually standing there with an old friend of mine, Chris Brown, some of you will know. And Chris just saw the message come through in an email or something that Oracle had acquired BEA Systems. So I'm pretty sure it's 2008. Yes, it was, yeah. And Oracle has done relatively little with message queue since acquiring it. BEA actually did some good stuff. Oracle has done relatively little with it since acquiring. I think they really wanted BEA's WebLogic product and just came along for the ride. And support for message queue on any platform now is somewhat limited. And it's certainly not going to be going to x86, okay? Oracle will not be porting Deck Message Queue to OpenDNS on x86, end of story. And that impacts a fair number of customers. How many people here have used Deck Message Queue at some point in their careers? Okay, I might have expected a slightly bigger number, but that's, I'll take what I can get. At the end of the day, there are still quite a few people out there, still quite a few companies that do rely very heavily on Deck Message Queue. So what can we do to help these people? It's because it does some things that are a little bit what I would consider abnormal by message queuing standards. It's not trivial to replace. What do you do? So walking the dog, Brett comes up with a cunning plan. Okay. And the cunning plan was, as per the first bullet point there, is let's devise a minimally disruptive, so not massive code changes on the customer's part, cost-effective and future-proof, i.e. standards-based solution to replace Deck Message Queue with my favourite Rabbit, or if you're here in Sweden, LavenMQ, which is developed by a company based up north here in Sweden, which is 100% compatible really with Rabbit, beside the point. The idea was, the cunning plan is to make this thing as close as possible to being a drop-in replacement. Not 100% possible, because like I said, Deck Message Queue does some slightly naughty things from a queuing perspective, but let's aim high. So that was the cunning plan, and we ripped into it. Well, I ripped into it, I guess. And the idea really, I suppose, is that last major bullet point there, that anyone who's familiar with Deck Message Queue and Deck Message Queue API, it's actually a relatively small and self-contained API. Some of the functions have an awfully large and disturbing number of parameters, but it's a fairly well-contained and clean API, cleanish API. It does some strange things, but that's okay. So my thinking was very, very simple. Why don't we create an API that looks exactly like the Deck Message Queue API, but under the hood it's speaking AMQP, which is the protocol used by RabbitMQ. Net result, drop-in replacement solution. Okay. So these are the functions, a couple of dozen functions, whatever, that are provided by the Deck Message Queue API. There are actually some ancillary functions that are largely irrelevant. But these are the main ones: functions for connecting to a queue, functions for putting and getting messages, for disconnecting, things like that. So, like I say, the cunning plan here is simply to create a new version of that API that uses the RabbitMQ API under the hood. And then you can chuck out Deck Message Queue, slot in Rabbit, magic happens, and you don't have to rewrite your C or Fortran application. Okay? So, this actually ended up working pretty well. There are maybe one or two things that need cleaning up, or perhaps that just won't work, but they tend to be more esoteric features. And where this solution stands today, as I said there, it can be used with C, C++, Fortran. We're in the process of importing the API for Linux, which is not particularly hard, and indeed probably Windows as well. Some of the remaining tasks, I need to put some timeouts on some of the API operations and a few things like that. But basically, this is a functioning solution, and we are talking with a couple of customers, one particularly big customer in North America, in fact. So that's the RabbitMQ deck message queue side of things. The Attunity Click conundrum. So, like I said, in 2019, 2019, Click acquired Attunity. And then in 2020, they promptly said, we're not supporting OpenVMS anymore. Not good, okay? Frustrating. Attunity actually always provided really, really good software. It didn't come cheap, but quality often doesn't. And they provided some really, really good solutions for data access. And in fact, I actually can recall working with Attunity many, many years ago, and reflecting on that, I would have to say that I think, Attunity were in some ways a little bit ahead of their time in terms of what they were doing in terms of their data access solutions. There are obviously alternative solutions. If you're an Attunity user, you might think, well, okay, I can use Connex, and for sure you can. Jeff and Dushan just did a talk on their REST API. That's great, but it's a different model. It's a REST API. It's not an ODBC connection like Attunity Connect or whatever. So if you wanted to use Jeff's solution, you're potentially going to have to turn your environment on its head in terms of how things work. Connex is maybe a little bit similar, but it's quite a lot similar to Attunity. But the change data capture tools that Connex provides work in a very, very different way and not really so real time as the Attunity change data capture solution. Another small company in the US called Trifox, who actually are looking pretty good. They provide a fairly good solution around RMS connectivity. If you want to query RMS files via SQL, which is essentially what we're looking at to a fair degree here. And we started playing around, how can we help these customers? How can we replace this Attunity change data capture solution for RMS? How can we, get some open standards in place here? What can we do? So we've actually done quite a lot working with customers and figuring things out ourselves and working with the likes of Pine to understand the requirements. And one of the things we've been working on is a change data capture solution that works much like the Attunity change data capture solution. And indeed, we're using some components, I'll come to that later, which Attunity solution had in common. The idea of change data capture, I'm not going to go through the whole slide. The idea of change data capture with RMS files or indeed with the database, someone makes a change. You insert a record, you delete a record, you update a record. You want that change captured, intercepted, if you like, and precipitated and published somewhere, right? There's something somewhere else in your organization that wants to consume that change. They want to know about that change. Maybe they go and stick it in a data warehouse, or maybe it goes in some other system. I don't know. I did a talk yesterday on event-driven architecture, which talked about a lot of this. Okay, so like I say, we've been working on this solution, and this slide is not entirely accurate. But essentially, like I say, the idea here is you've got applications that are making changes to your RMS, your indexed RMS files. Those changes are intercepted, they're consumed, and they're published via some mechanism or another. It could be via a protocol like AMQP, it could be to a Kafka stream, whatever you like, okay? So this is sort of the general idea of what we're aiming to build or have indeed built. The solution has transformation capabilities. So if our CDC consumer process on that previous slide, if that gets an RMS record or RMS record, it can do some magic with it and maybe transform it into JSON, or it can convert UICs into usernames and so on and so forth. Standard stuff, it can handle all the data types. And like I said, you can then have those records published to wherever you want to go using the protocol of your choice. So this solution is still evolving. And, I use the word solution here because that's exactly what it is. You can't shrink wrap this thing and give it to a customer as a product alone. It has to come with some services. Solution equals product plus services. Pine can tell you how much time he's been away from home, traveling around the world, working with customers to get things working with the Trinity change data capture.
The demo was 1 hour. The implementation is 2 months.
Yeah. I can remember I think was it somewhere in South California, you spent 2 painful months on a lovely beachfront. Anyway, so, this solution is starting to take very, very good shape with input from mine and talking with customers and things like that. And, we're going to carry on, hopefully, and as I say, turn this into something where we can actually really do good and help those Trinity customers who no longer have support. Now, when I was working on this thing, the core engine of it obviously understands how to do things with RMS files. I'm being a bit vague and fluffy here because it would take too long to explain it all. And again, walking the dog or doing something like that, it suddenly occurred to me that I had this core engine that actually knew how to process RMS files, it understood indexes, all that sort of fancy stuff that you get in RMS, or most of it at least. And could I put an SQL interface over the top of this and therefore provide something much like the Trinity Connect solution, where you can just type an SQL statement to select a record, select star from sysuaf where username equals Cameron, for example, right? And so that's exactly what I managed to create. And I won't bore you with the gory details, but essentially, what I did here was I thought, well, I'm not writing my own SQL engine. That's like really hard. That's more than a weekend's work. So what occurred to me was that good old SQLite, right? That little wee embedded database. SQLite actually has a mechanism where you can define virtual tables, and then essentially via a shareable image, I could hook that in with this core engine I had that understood RMS files. So all of a sudden magic happens. This thing actually literally worked the first time I built it. And that makes me nervous because, when something works the first time, you think there's something wrong. You expect an access violation or it just blows up in your face or whatever, but it worked really, really well. So the diagram there is just a little command line utility that I've got. So, select star, count star, select how many records are in sysuaf. Boom, you get the answer. And then select star from sysuaf where username equals pickles, right? What I'm not showing you there is how I've defined the structure of the sysuaf file and things like that. But, that's just configuration stuff, no big deal. The other really kind of cool thing, again, because I'm inherently quite lazy and I don't like writing more code than I have to, and I also like standards. So it occurred to me, I'm not going to write my own wire protocol to communicate with this damn thing that I built. I'm just going to use the Postgres wire protocol. What does this mean? It means that my client, if any Postgres client, whether it's an ODBC client or the Linux command line tool, whether it's embedded SQL in C code that's pre-processed by the Postgres embedded SQL preprocessor, can now talk to RMS files via this interface, okay? Magic. Yeah, like I said, I won't bore you with the configuration. It gets complicated. So that all worked. And like I said there, this then gives you remote programmatic access via the Postgres wire protocol, talking to indexed RMS files sitting on VNS. Cool. I earned myself a hearty beverage that day. Right. Trinity also provides a stored procedure call mechanism. What this really is, it's kind of an RPC mechanism, but from SQL. We have customers that use that stored procedure mechanism within Trinity. Now, this is nowhere near as advanced, but essentially there's a prototype starting to creep into what we've got that allows you to do that. Now, the slide I've got there, and Hein will probably shake his head and so forth, but it's what I came up with first. We can change it, don't worry. But the slide I came up there is essentially the interface definition language, the IDL, that defines the interface, what those stored procedures look like. And the idea is that will be built into that Postgres wire protocol engine, and you will then be able to call stored procedures, which are basically just functions in a shareable image, via the same Postgres wire protocol mechanism. Okay, IBM MQ. So back to the message queuing, a little bit of history. In the 2000s, there was a gentleman by the name of John O'Hara who worked at JP Morgan Chase in London. He was in charge of the middleware group. John O'Hara got really, really annoying because every time you do a new project, you suddenly found yourself with some new integration tool and they wouldn't talk to each other and so forth. So he decided to be disruptive and disrupt the whole message queuing infrastructure of the world, if you like. And he came up with AMQP, the Advanced Message Queuing Protocol. The net result of what he did was that all of the major message queuing vendors like TIBCO, IBM with MQ, suddenly realized they couldn't just kind of sit on their hands and stick with their old proprietary protocols. Their solutions had to support standards. So message queuing products like IBM now support MQTT, Message Queuing Telemetry Transport Protocol, which is common to the Internet of Things. It supports the AMQP 1.0 protocol, and it also provides a REST API. You know, so those of you who are in Jeff and Dushan's talk, where Jeff has the REST API for querying RNS files and RDB, you can now use the REST API to communicate with IBM MQ server. Okay. Now there are some limitations, and I'll talk briefly about that. But the bottom line is that because of that disruption that things like these standards, MQTT, AMQP, caused, you can now interface with products like IBM MQ in different ways, and potentially less expensive ways. So I'm not going to go through all the nonsense about what a REST API is and so forth. But essentially, the REST API that MQ supports is kind of limited. You can obviously put messages, you can get messages, you can actually have a bit of a look at a message and decide whether you want it or not. It doesn't take it off the queue, it just gives you like a copy of it and to have a peek. So there's quite a limited interface, but for most work that customers do, you know, it's quite sufficient. Okay, you've got to appreciate some of the limitations of HTTP. It's not going to be anywhere near as fast as the native protocol of MQ or anything like that. But again, for many applications, this is more than sufficient. So we had a customer talk to us. I think Jan and I were having a call with this customer, and they said, you know, is there any other way we can do what we're doing here with MQ? And I said, well, yeah, look, you know, we can do something with the REST API. So what we ended up developing is essentially written in C, essentially an API that they can use in their programs. I think they're mostly in Fortran, but don't quote me on it. It doesn't matter. It's a language agnostic VMS style API that you can use on your open VMS systems as a client to be a client to IBM MQ to get messages, whatever, and you don't have to pay IBM for MQ client. Now, like I say, I mean, that's great for some use cases, not so great for others, but, you know, it's just something else that you might be interested in that we've done. So I think the example there, yes, it is in Fortran, rather horrible looking Fortran, but that's beside the point. MQTT, I'm not going to spend too much time on this. MQTT actually was devised by an IBM scientist to detect when he has an old house on like the Isle of Man or the Isle of Wight, I can't remember which, and he had this minor infestation of mice. So he set up these mouse traps, and in a mad fit of boredom, he embedded the MQTT protocol so he could monitor and control these mouse traps when he was traveling. And yeah, Andy Stanford Clark was his name. And essentially, he then found himself doing a project with a customer on some oil rigs, I think it was. And he thought, aha, my mousetrap thing could be useful here. And that's how we ended up with MQTT. So you can talk to newer versions of IBM's MQ series message queuing bus via the MQTT protocol if your administrator has enabled it for you. And we have the Paho C client that works on OpenVMS. And we do actually have, I would say, several customers, but one very, very significant customer actually doing this in the financial services industry. Within their application, they are communicating with MQ via the MQTT protocol as opposed to the proprietary protocol. Yeah. I also mentioned that MQ series and new versions of MQ can now communicate via the AMQP 1.0 protocol. We can provide you with Cupid, which is an open source Apache project. The Cupid API is a full AMQP 1.0 client that you can use to integrate with IBM MQ via AMQP 1.0. It also allows you actually, now that I think about it, to communicate obviously with any other AMQP 1.0 data message broker. It could be ActiveMQ, that could be Microsoft Service Bus, it could be Microsoft Event Hub, whatever. Okay, so this exists. Give you a kit tomorrow. Not a problem. Now, like I said, this is quite good news for MQ users. We've got some more options, they're standards-based, et cetera, et cetera. But you need to think about your use case, right? HTTP is never going to be as fast as the proprietary IBM MQ protocol. You don't have the full breadth of functionality in terms of things you can do. You can't do pub sub over HTTP. You can't publish subscribe over HTTP. You can only really put and get messages, right? Pub sub makes no sense in an HTTP concept, really. So you need to understand, Brett, this sounds cool, great. But is it right for your environment? Okay, so think about it. And obviously we've got IBM MQ client for OpenVMS, Willow Technologies provide that. So we're not looking to put the guys in Willow out of business or anything like that. Quite the contrary. This is all about providing customers with alternatives, with options, and to try and stimulate some ideas about what may be possible. Okay, in 2020, does anyone know who the picture is? Yeah, the English people. Yeah, I won't go into the details. Famous English television comedy, Dad's Army, back in the day, showing my age. But in any way, back in October 2020, Oracle announced, right, that's it. We're Oracle 11G or whatever version it was. It's going to be the last version on OpenVMS. It's going to be supported and no client, et cetera, et cetera, et cetera. So again, customers with a problem, how can we help them? So a little bit of Googling, I found this thing called SQL Relay. Now, the guy that wrote SQL Relay did an incredible job. This is a nice piece of software. He's done a really, really fine job of implementing this thing. And so what we've done is we've ported the SQL Relay client to OpenVMS, and we've added some extra bells and whistles, which I'll talk about shortly. But basically, I suppose you could liken SQL Relay a little bit to ODBC, but the difference is that the gateway, the interface bit to the database is actually kind of more on the server side, or possibly in a separate box or in a container, as opposed to the ODBC driver that you're linking into your application. So essentially, what this means is your application code on OpenVMS is calling SQL Relay API as opposed to the Oracle API, and it's talking through the SQL Relay server, which might be on a Linux box somewhere or in a Docker container, and that's using the standard Oracle client to talk to the database. Now you think, okay, Brett, well that's cool, but you've just gone and introduced an additional moving part. Something else that potentially breaks, something else that's adding some latency. You're not entirely wrong, but if you go and read the SQL Relay documentation, you'll see, like I said, this guy's done an incredibly good job, and there are a myriad of options that you can put in there around redundancy and fault tolerance, and also to achieve better scalability and performance. And the net result really is that you're not losing much, if indeed anything. Okay, so it's been well done, well engineered piece of software. So we ported the client, as I say, to Alpha, Integrity, and to x86. But most customers, of course, have embedded SQL or something like that. But they've got Pro C programs. They've got C code with embedded SQL that they run through the Oracle preprocessor, and so how does that work with SQL Relay? So what we've done is some smart guys in the team here in Denmark actually did a great job of implementing an embedded SQL preprocessor for C and COBOL. Probably the COBOL one is more advanced, and Alex is having a look at doing some work at the same sort of thing around Fortran as well. So all in all, this equates to a fairly good solution. There are some gaps. While SQL Relay does provide tools for, command line tools for interacting with the databases from OpenVMS, it doesn't have like SQL Loader. So if you rely on SQL Loader to load millions of records into your Oracle database really, really quickly, we'll have to have a discussion about that. It supports a myriad of data sources. In addition to Oracle, it can do DB2, MySQL, and MariaDB. It can do ODBC in a generic way, it can do Sybase, SQL Server, Postgres, whatever. The diagram over here is there's a nice little blog post. You probably can't read the link, but you can Google it. So Arm is based in the US, a member of the VMS community. He latched onto this and had a really good play around with it and did some great work testing it and put together a nice blog with all sorts of different combinations of data sources. So, like I said, we've developed embedded SQL preprocessors, C and COBOL, and we've also created a Docker file that allows you to, basically put the gateway in a Docker container. We have a number of customers using that. In terms of the embedded SQL and COBOL, we've got one customer that will be going live on x86 using this probably around the end of summer, September timeframe, I think. And we work very closely with them to make sure that we could actually parse all of their embedded SQL and generate equivalent COBOL code that uses the SQL Relay API. So I won't say too much here, but again, referencing Arn's article, really. And these are just some of the combinations that he tested in his experiments, with VMS talking to all these different data sources using SQL Relay. Other data access solutions, FreeTDS. FreeTDS has been around for a long, long time. It was first ported, I think, by Craig Berry, who some of you will know from the Perl, Perl for OpenVMS. FreeTDS can be used to communicate with Sybase, SQL Server. They both use the same protocol, the TDS protocol. And so, we have this nicely packaged up, and we've also added some goodies there as well. We have embedded SQL preprocessors for both COBOL and for C, and these work pretty well. Okay. Unix ODBC, that's been around for a while on OpenVMS as well. We haven't done too much with that. We didn't have to, but there are drivers available. So this is just a standard ODBC implementation, much like it would be on Unix or on Windows. And there are ODBC drivers for various databases on OpenVMS, Postgres, MariaDB, MySQL, Sybase, and SQL Server via FreeTDS. Obviously, on Integrity or Alpha, you can still use the Oracle client. So you can use an Oracle ODBC driver. There's a driver for NEMA, et cetera, et cetera. So you can have some fun here with this and connect to different data sources, much like with SQL Relay. Interacting with RDB in new ways. So I mentioned that little SQL solution for querying indexed RMS files. I thought, why don't I have some fun and stick that same protocol on top of RDB, right? You've got SQL services, but why not add something else and use a standard wire protocol? So taking that engine that I've developed for the RMS thing and basically applying it to RDB, from your Linux box, your Windows desktop, whatever, you can now query RDB tables via the Postgres wire protocol. One of the fun things you can do here is essentially create database links. So you might have a Postgres database on Linux, and you can actually hook that through to, you do a query of your Postgres database, whereas in fact it's actually talking to an RDB table on the VMS, right? So this thing actually works pretty well. It uses standard SysUAF, or it can actually also do external authentication if that's what you want to use. About the only thing missing, there's a couple of things missing, but probably the main one is that I need to get SSL support in there, but that's not a big deal. And there's one or two other bits and pieces, but this thing works really well. A couple of other things. I've gotten through this a bit faster than I thought I would, which is great. The guys from MEMA did a talk yesterday about migrating from RDB to MEMA. Great. I created a tool to do that back in 2006, and for a project that I was working on, I recently resurrected it. I thought, well, the tool I wrote back in 2006 was to actually help a customer I had in New Zealand migrate from RDB to Oracle Classic. But the RDB side of it, it's the same. It doesn't matter what the target database is. You've got RDB there. So I had all that functionality for dealing with the RDB side of things. And using Unix ODBC, which I just talked about, I can now, basically by typing a few commands, I can replicate an RDB database schema in any of the databases I've listed there. And I can also, by typing a number of commands, I can say, copy these tables from RDB into this other database. You may not want to do that because if you've got like several terabytes of data, that's not really the most efficient way of moving the data. But, it's quite an interesting little tool for doing some of this stuff. And I think I've got a few slides on just some of the capabilities that it has. Data transfer operations, like I said, maybe you don't want to do that with because it uses direct SQL, so it's not necessarily the fastest way of getting a billion records, across the network into your new database. It'll handle table creation, it'll handle index creation, constraints and so forth. It also allows you to do things. The customer I was working with back in 2006, we had situations where there were reserved words in RDB, or there were reserved words in Oracle Classic that were not reserved words in RDB. Okay. And so we built in this ability to have substitutions. You basically creates a table in the application of, if you see this thing, replace it with this, which is kind of cool. And parallel processing capabilities, you can spin up a whole pile of batch jobs of the tech processes, I don't remember which, and they can copy tables in parallel. Okay. I mentioned there, I also hooked this thing up because, moving data from one database to another can sometimes be a little bit slow. So I've actually hooked it up so you can pump the data into something like a Kafka or a RabbitMQ stream. And depending on your record size and a few other factors, it's quite easy to say do 10 or 20,000 records per second via that interface. The other thing that we've done, which some of you I know are aware of, is, and we needed this for various purposes internally, right? So we created kind of a partial CDD replacement because there are products that we needed to port to x86, but we needed CDD to do it to a degree. So what we've done is we've actually developed something that is a partial CDD replacement. It understands all the CDO syntax, it works with compilers, it works with ACMS, it almost works with datatrieve. So forth, right? Is it perfect? No, but it's looking pretty darn good. So that, that's also potentially useful for those customers who maybe don't really use something like RDB for their data storage, but they have to have it because they've got a secondary data dictionary. This thing just stores the data in SQLite, no big deal, easy to back it up, just copy the file somewhere else, it's whatever. So that solution's actually looking pretty good. There are some gaps, but fundamentally it's in pretty darn good shape. And just one last thing, Alex talked this morning about some work he's been doing around REST APIs and integration with legacy code and so forth. And we do have other solutions in this space, and the one Alex is working on is actually really nice piece of C++ code. So I shouldn't steal his thunder, but this is one that we've got that's pre-existing that allows you to develop REST APIs, server and client actually, relatively easily on OpenVMS systems. And I'm pondering the notion of actually replacing one of the bits with some of the stuff that Alex has been doing because I think it would give better results. But the fundamental premise in the little box there is essentially within the Rivet tool, I come up with silly names for things within Rivet. You define your service, you define the paths if you're used to developing REST APIs. So I've got a path called demo2 sum. So sum is the path, demo2 is the name of the service. If somebody requests that path, it's going to execute a function called cob_sum, COBOL_sum. It's going to add a couple of numbers together. So basically, you put your business logic, you put your functionality into a shareable image. Rivet knows how to load that shareable image, and you set up the entry points. You map the entry points in the shareable image to URLs, essentially, and you start the server. Now, as you probably guessed from the name of the function, cob_sum, this particular example was written in COBOL. The web server supports multiple threads. What could possibly go wrong? So you can actually say how many threads you want to use. Now, obviously, that's not going to scale terribly well with one thread. So, there are other ways of dealing with that. And I won't go through the demo, but there's a bit of a clue there. If you're working with languages like that are not thread safe, COBOL, BASIC, Fortran, what you can actually do instead is Rivet has hooks into our WSIT product, the Web Services Integration Toolkit. WSIT understands legacy applications. So instead of dealing with threads, it will spin up a pool of worker processes, right? Single-threaded worker process. And Rivet will, instead of calling the shareable image directly, it will actually call the server running under WSIT. Okay, so that's kind of a high-level overview, that picture of how this thing hangs together. multi-threaded web server, configuration, ability to talk to WSIT, ability to call directly into shareable images, hooks into ACMS, and your client can be whatever you want your client to be because they're all HTTP requests that conform to the REST standard. Okay, and Kiara actually did a really good job of reorganizing my slides. I thought I was going to be in real trouble there, but it's worked out okay. So this is a somewhat random selection of things that we've been playing around with. Hopefully some of them are useful to you directly, or at a minimum, hopefully they've got you thinking about other things that you might be able to do within your environment, okay? And we're always happy to hear from you. Like I told the story yesterday about, you talk to the insurance guy or the bank, and the last thing they say is there anything else we can help you with, sir? If there's anything else we can help you with, let us know. Yeah. Over and out. Questions? Any questions? No? I'm standing between you lot and coffee, so go for it. Thanks for your time.